Hey everybody, Trey here, back with another forecast discussion today. I wasn't actually planning on doing a forecast discussion this morning for the event that will begin tonight into tomorrow. I was going to do it on Tuesday morning since the main sort of threat with this event was going to be tomorrow afternoon. But there have been some significant changes to the overall outlooks, both categorically and the overall area of the threat. So I thought it'd be good to do a forecast discussion, take a look at some of the new data that's come in, and kind of update my thoughts a little bit on the event going into tomorrow, tonight and tomorrow. This may be my last forecast discussion on this particular event. I may or may not do one tomorrow morning, but since this is going to be kind of a fluid event, things will start this evening and kind of just flow into tomorrow and tomorrow afternoon across the threat areas. This may be my last forecast discussion on this particular event. But the big change for the event portion of the event that will begin tonight into the overnight hours tomorrow morning is there's been a slight risk added from northwest Kansas down through the Oklahoma Panhandle, northwest Oklahoma, down through the eastern Texas Panhandle into northwest Texas. There's been an increase in the overall tornado threat. There's now a 5% area all the way within that slight risk area from northwest Kansas down through the eastern Texas Panhandle, northwest Texas into western Oklahoma, places like Colby, Garden City, Dodge City, Liberal, down toward Woodward, and places in the Texas Panhandle like Canadian, down toward Turkey, Childress, Vernon, Wichita Falls, all in the main tornado threat area for this evening. Damaging winds and large hail will be a threat as well. And then tomorrow, the enhanced risk area has been shifted a little bit farther to the south across parts of East Texas into northern Louisiana. Now includes places like Lufkin up toward Shreveport, down toward Alexandria. Strong tornado threat does exist tomorrow within that enhanced risk area, 10% hatched area there, for the threat for maybe a strong tornado or two. There will also be a damaging wind and potentially a large hail threat as well. So let's go ahead and get started here. We're going to start with the Monday into Tuesday morning portion of the event first, and then we'll flow into the Tuesday portion of the event in the latter half of the video. Let's start off with our water vapor satellite imagery, as we always do. And the one thing that jumps off the page at you is this big old swirl across the western half of the continental U.S. That is our main trough that is going to be the impetus for severe weather over the coming couple of days. You can see it's a very high amplitude, very wound up trough that is making its way in. So the forcing with this trough is not going to be subtle at all. It's a very potent trough, and we'll go into detail what that means a little bit later. Visible satellite image showing that we are pretty much entrenched in this low kind of cloud deck here across the southern plains. I looked outside this morning here in Norman, and there was a little bit of some light fog hanging around. And you can see it's kind of still kind of hanging around, the low clouds, slow to burn off here across the southern plains. You can see with western extent, we are starting to get some sunshine moving into southwest Kansas, the central Texas Panhandle, down into west central Texas there. So we may slowly get some surface heating to help destabilize the atmosphere, but the potency of this trough and the cold air aloft associated with it is going to be the main destabilizing factor here for at least the portion of the event tonight into tomorrow morning. If we look at our 500 millibar chart here, you can see where that trough is, very wound up right across the Nevada-Utah border vicinity. Very strong winds rounding the base of this trough. And you can see these red contours, these red dashed lines here are the isotherms, or temperature contours here. Tells us how cold or warm the air is aloft. And you can see, usually I like to see temperatures about minus 18 to minus 20 degrees Celsius to consider that air cold near the center of the system. And we're seeing temperatures in the minus 30 degrees Celsius range here. You can see minus 30, minus 32 there. That is extremely cold air aloft associated with this 500 millibar trough. And that is going to be overspreading the central and southern plains this evening. And that will really help destabilize the atmosphere despite maybe a lack of low-level moisture, at least in the initial stages of the event, that usually would help destabilize the atmosphere. Instead, we're going to have to rely on the thermodynamics associated with this 500 millibar trough. We'll go up to 300 millibars here. Just a quick note, the diffluence aloft, the spreading apart of those wind vectors is extremely notable with this trough here. You can see over Colorado and Utah there, winds out of the almost due south there at 300 millibars, whereas over Texas here, almost out of the due west. So very strong diffluence aloft. And again, diffluence aloft is the spreading apart of those wind vectors with height. Divergence is the spreading apart of those winds with height. and that creates a void in the atmosphere, and the atmosphere doesn't like that, so it brings up air from below to help fill that void, and that is how you get large-scale rising motion or ascent that is favorable for severe storm development in a given scenario. So very potent trough here, very favorable for initiating some unsettled weather here. Let's go down to 850 millibars, take a look at our low-level jet here, and you can see we've got a very large swath of low-level jet extending all the way up into Canada there, extending down into south-central Texas, 30 to 35 plus knots of flow there across the entire region. And that is in response to this very strong low-level cyclone here that is beginning to develop across the Intermountain West region. We'll go down to the surface in a second to show you how it's developing at the surface, but very strong cyclone here. As a result, the mass response is very, very strong with this system. It means that that flow in the low levels is going to really start to strengthen and back out of the south, so we can get that moisture pumped up into the region in preparation for this severe weather event, and also increase the wind profiles for potential severe weather with these storms later this evening. We'll go down to the surface here and show you what is going on at the surface. And you can see we've already got a very strong surface low that's developing across central Colorado. As we know, as that 500 millibar flow traverses the Rockies out of the southwest or south-southwest, as it is in this case, as it goes over the Rockies, we get surface low development on the lee side or east side of the Rockies, and that's exactly what is happening here. Very strong surface low starting to develop here across central to eastern Colorado. And you can see that the pressure gradient has really tightened out here across these central plains. These isobars here are very, very close together, and that indicates the potential for very strong winds. So wouldn't be surprised to see very strong winds here as a result of the mass response associated with this surface low development. Those winds at the surface going to continue to back out of the south or south-southeast and really pump that moisture that is sitting right over the Gulf into the southern portions of Texas, going to pull that northward throughout the next several hours into the evening and into tomorrow for this severe weather event. Let's go ahead and take a look at our current surface data here. We'll start with our southern plains sector. Actually, we'll go up north here, and you can really see that surface low start to develop here. You can see kind of the cyclonic flow, kind of broad cyclonic flow that's starting to develop here across kind of central to eastern Colorado there as a result of that surface low. And again, that, if you recall a couple days ago, we talked about that the winds were kind of, or yesterday we talked about the fact that the winds had been kind of out of the north and had the preceding cold front that initiated some marginally severe storms across southeast Texas over the weekend. That had pushed off and kind of shunted all the moisture down into the Gulf. But you can see that moisture not far off here, 70s dew points sitting across the southeast Texas coast there, with low to mid 60s dew points across central to south central Texas there, ready to be pulled northward. You can see the winds have switched around to southerly or south-southeasterly here across the region, and those will only strengthen and continue to back with time as we go through the day today, and that will really help to pump this moisture northward. Now, initially, we're going to be a little bit on the weak side as far as moisture goes. That moisture is going to take a little bit of time to make its way northward. However, we already are having 60-degree dew points all the way up to about Abilene here, which is maybe a little bit faster than what the models were showing. So that may mean we have a little bit more robust moisture return than what was being anticipated by the models, maybe just slightly. So that's something to note there. We have basically upper 40s to low 50s dew points across the main kind of target area here, across the slight risk area for this evening. So early on, moisture may be a little bit meager, especially with northward extent, but again, the overspreading of those very cold temperatures aloft associated with that 500 millibar trough will help destabilize the atmosphere, when normally we'd like to see a little bit stronger moisture returns and some surface heating to really destabilize the atmosphere. Instead, we're going to have to really rely on that very cold air aloft with this trough to help destabilize the atmosphere. Let's look at some soundings here from this morning to see what the atmosphere is looking like in the vertical. This is at Norman at 12Z, so 6 a.m. Central Standard Time here. Very strong inversion here at the surface, again, well to the north of that warm front, that leading edge of the stronger moisture return. You can see here 47-degree dew point with a 47-degree surface temperature at 6 a.m. That's why we're seeing a little bit of that fog, that surface temperature and dew point about the same there. So we're seeing some very, very low cloud development there that turned into some light fog this morning. Few strong inversions here. You can see a couple of kind of stair-stepping looking skew T profile there in the atmosphere, and it's even more pronounced there at Dallas. So you can see kind of that zigzag in the temperature profile there. So a few inversions to deal with today, and some slightly drier air aloft, actually significantly drier air aloft here at Dallas-Fort Worth. So again, it's going to take a lot to fully destabilize the atmosphere, but that air aloft is so cold that I think it's going to be able to do so, especially as we go into the evening hours tonight. We should start to see full destabilization here across the warm sector as that moisture moves northward ahead of the dry line. A little bit farther south here, we'll go to Del Rio. You can see we are now starting to kind of get into the warm sector, 60-degree dew point there this morning at Del Rio. Fairly deep, moist layer there, extending up just above 850 millibars, and you can see some semblance of that elevated mixed layer there here at Del Rio. Very stout lapse rates there and some drier, warmer air there in that layer. Just above about 800 millibars there at Del Rio. Again, the elevated mixed layer, we talk about it almost every video we do. It's that layer of very warm, dry air aloft, those steeper lapse rates that emanates from the desert southwest and western Mexico that gets transported across the region. It helps cap the atmosphere in a given severe weather scenario. And that's going to cap the atmosphere for most of the day until that forcing moves in and starts to erode that cap, and that cold air aloft starts to destabilize the atmosphere very rapidly. Hodographs, though, down to the south here especially, already favorable for supercells and severe storms. Very long hodographs here, 0 to 6 kilometer wind shear of 50 knots, with some very strong curvature there in the low levels, meaning that warm advection is well underway at Del Rio, or was well underway at Del Rio this morning. All right, let's go into some model data here. I'm just going to take a look at the NAM. Our video yesterday looked at a few different models. I'm just going to take a look at the NAM for the most part because the overall pattern has pretty much worked itself out now. And there's just some slight differences on the low-level moisture that we'll look at with the GFS and the HER. But the overall pattern with the NAM looks pretty good, so we're going to just look at that for our overall pattern with this event. So 12Z NAM initialized here. You can see that trough centered over the Intermountain West there. Very strong flow rounding the base of that trough. That will continue to move in as we go into the next few hours. And by about 0Z, we finally start to see the coinciding of that stronger flow aloft, that divergence or diffluence aloft, with that returning low-level moisture ahead of the dry line, which should be placed somewhere in western Kansas to the central or eastern Texas Panhandle there. So moisture will be right in here. That forcing starts to overspread the region by about 0Z or 6 p.m. Central Standard Time here. So would expect to see storm initiation right about sunset or just after this evening. The first set of storms may start here up in west central to southwest Kansas, maybe into the Oklahoma Panhandle, northwest Oklahoma, far northeast Texas Panhandle, as the main forcing kind of is right in there, at least initially, and that's where the colder temperatures aloft are. You can see the grays here are those very cold temperatures aloft, and you can see those start to impinge into the region by about 0Z this evening. So we will rapidly start to destabilize as we go towards sunset and just after, and that's when storms should start to fire there, especially with northern extent into western Kansas. Low-level jet here we'll take a look at. You can see that broad swath of some moderate low-level flow there, and that only will increase throughout the day as we get that low-level cyclone to really establish itself and its associated mass response here. You can see 50-plus knots of flow up into Nebraska, extending down into central Texas there. So wind profiles with this event should be very, very strong, and overnight the low-level jet only strengthens with time, as we often see nocturnally here in the central to southern plains. Surface pattern here, you can see that surface low across central to eastern Colorado really starts to take shape this afternoon and really starts to back those winds and strengthen those winds at the low levels out of the south or southeast to pump that moisture northward. And that low will start to move off into the central plains, off toward the east or northeast by Tuesday morning. And we really should start to see a surge in that kind of dry line cold front position going toward midnight and after here. Let me zoom in to our moisture, our dew point fields here. So you can see, so we're at about 19Z right now, so 18Z. If we go back to our surface map, the NAM was initializing 60s dew points all the way down here. Basically, this is San Antonio down here. And the 60s dew point line was barely just to the north of San Antonio. And you can already see we have 60s up here on our latest surface analysis up toward the Abilene area, just south of the Dallas-Fort Worth area, actually. So our 60s dew points are looking like they're much farther north than what was being progged, at least on the morning model of the NAM, morning run of the NAM, excuse me. And if you recall our video from yesterday, the NAM was actually the least aggressive with moisture return and it still remains that way, whereas the GFS was much more robust with moisture return. And if we look at the GFS here, it's a little bit farther north with that 60-degree dew point line, maybe still a little bit less generous with the moisture return here with this particular run of the GFS. So this is an interesting development here with the latest data here on the GFS. GFS is still much more robust here, and we'll look at Tuesday in a second and how far that moisture gets northward here. But the NAM is a little bit on the slow side with moisture return based on what we're seeing right now. Again, so if we look at Abilene, which I believe is right here, 55-degree dew point at noon today. This is just afternoon, and you can already see Abilene is right in here, 57-degree dew point, 60 here at that station right there. So moisture is looking a little bit more robust, moisture return looking a little bit more robust than what the models were progging this morning. But nonetheless, over time, we do get the development of that return of that moisture northward, and you can see these red contours here start to peak into western Kansas by 0Z. These red contours are the lifted index, and that's just another measure of instability. We've talked about it before on the channel. It just takes into account the temperatures aloft, and it's a basic sort of formula there that tells us how unstable the atmosphere is. So anywhere there's red contours means that there's some instability in the atmosphere. And by 0Z, we start to see that creeping in. And by 6Z, we really get that creeping in across West Texas West Kansas down into the Texas Panhandle, Northwest Oklahoma there. And I want to take a sounding. So even though the 60-degree dew point line is still well to the south, we are getting destabilization far to the north because those cold temperatures, keep an eye on the grays here, really start to impinge into the region here. So that cold air aloft is rapidly helping to destabilize the atmosphere with northern extent. I want to take a sounding here from the northern portion of the area here. We'll take one right at the Oklahoma Panhandle, Kansas border. And this is going to be extremely reminiscent of a cold core setup. This is almost a classic sort of cold core type setup. And we've talked about cold core setups before. This is the video I did in the last, about a month ago, on cold core tornado environments. I'll put the link to this in the description below. But this is a sample sounding from a sample cold core case that I looked at in that video. And take a look at how similar this is. Look at the instability profile with this one. Very much concentrated in the lowest levels of the atmosphere. Very fat cape in the lowest levels of the atmosphere. And that's exactly what we have going on here. All that cape, even though it's only under 1,000 joules per kilogram, it's all concentrated in the lowest levels of the atmosphere. And it's very, very fat cape, as we say, kind of colloquially here. So even though these storm tops may be, 20 to 25,000 feet at most, maybe 30,000 feet at most, they're going to be low topped, but they will have the chance to produce, will have the chance to be supercells, potentially tornadic supercells, because we have a very strong wind profile associated or coinciding with this very strong low-level instability. So you can see the winds veering in the low levels there, strong clockwise curvature of that hodograph, and we've talked about before, when you have strong low-level instability, you can see 3 cape here, 233 joules per kilogram of 0 to 3 kilometer cape. That is off the charts, and a classic sort of sign. Classic parameter for cold core tornado events is looking at that 3 cape. It's all concentrated here in the lowest levels. So any spin in the low levels, very strong low level shear here, that vorticity in the low levels is going to be very, very efficiently stretched into the vertical. And any supercell, especially any discrete supercell in this environment, will have the advantage of taking, or will have the chance of taking advantage of this very strong shear and stretching it efficiently into the vertical to produce a potential tornadic circulation. And I've honestly never seen a cold core event at night. Oftentimes you want to see that assistance from some surface heating to help destabilize the atmosphere. But the air aloft is so cold with this event. You can see here at 500 millibars, if we trace it all the way back down, it's like minus 24, minus 25 degrees Celsius here, where I took that sounding, and even colder farther to the north and northwest. That super cold air aloft is going to be able to destabilize the atmosphere almost fully here. Maybe a little bit of some remnant inversion down here, but even though the dew point and surface temperature at 53 degrees, because that the temperature dew point spread is low, because we have all that instability situated in the low levels there with such strong low level shear, would not be surprised to see a few tornado reports from this overnight portion of the event tonight. Farther to the south, across where the better moisture is, I'll take a sounding as well. We're going to see so much of the same down here. Again, this is at midnight tonight. Much of the same, a little bit more of that EML in play here. You can see that inversion sticks around a little bit longer, but we do have a lot of that instability started kind of aggregating down here in the low levels with very strong low-level shear, long photographs favorable for supercell. So I think with southern extent, because we have a little bit of that elevated mixed layer remaining, we're going to have to rely on the frontal forcing here. So initially, storms will probably fire up here into western Kansas down to the northeast Texas Panhandle, northwest Oklahoma vicinity. And then once that cold front / dry line starts to surge to the east, that's when we'll start to see storms fill in with southern extent down here, southwest Oklahoma, southeast Texas Panhandle, northwest Texas, where the better moisture is. And you can see that moisture will continue to surge northward into the overnight hours and early morning hours tomorrow. Given the degree of forcing, there, you can see how quickly that front kind of surges off toward the east, especially after midnight. We should get more of a line of storms here, although we don't get a whole lot of movement with the dry line here until about midnight. So there may be a window between about 0Z and 6Z, or between about 6 p.m. and 12 a.m., where we may see more of a discrete mode up here with the initial storms up into southwest Kansas into northwest Oklahoma. So something to watch there. Any more discrete storms in this environment would have a chance to produce tornadoes, given such a strong, such a good-looking kind of cold core type environment here. And then with southern extent, especially once that cold front starts to take over, once the forcing really starts to move in, we should see a strong increase in the coverage of storms along this front. And therefore, we will see more of a linear organization to the storms with time, especially as we go into tomorrow. That forcing will continue to move into the region and help those storms maintain themselves through the morning hours along the frontal zone here as they move off toward the east. Places like Dallas-Fort Worth, the threat is going to be greatest there, Dallas-Fort Worth to Waco, in the morning hours Tuesday, probably after sunrise as that line moves through. And then, once again, I'll zoom back out here and kind of show you the overall progression of the trough. You can see the trough here starts to move off toward the northeast. We still have a strong belt of flow here across the southern plains, and that, again, will help maintain that line of storms throughout the morning and into the early afternoon hours Tuesday. Even though the main surface low is going to start lifting away from the region, as we talked about in our video yesterday, it's going to start to occlude. That cold front associated with this system is going to eventually catch up to the warm front here and overtake it. So you go here, and then we start to really occlude by Tuesday afternoon. Our cold front is right in here. Our warm front leads back into the center of the surface low right in here. So right in that portion of the surface low where those frontal zones meet, that cold front will have overtaken the warm front, pushed that warm air off the surface, and that's what we call the occlusion process. And that means that the system is overall it's past its peak, if you will. It's going to start dissipating at some point soon as that warm air gets cut off from the center of the low, and we will start to see the dissipation phase underway. But that surface low will start to move away from the region. It will kind of leave the warm sector behind. That forcing, though, will continue to push that cold front off toward the east Tuesday afternoon, and we will see a continuation of the severe threat into Tuesday morning into afternoon. Now, the NAM, once again, is a little bit stingy with moisture return, and that's, I think, why the SPC has kind of moved the threat area farther south here across the region. It's because you can see up here that the overall warm sector is very, very pinched with northern extent, but we have a much wider warm sector with southern extent, maybe a little bit farther removed from the overall forcing, but we do have a much wider warm sector down here. Let me take a sounding out ahead. Again, we'll have, at this point, this is 3 p.m. Central Standard Time Tuesday, we'll have storms ongoing along this line. And we're also going to have to watch for maybe some discrete development right out ahead of the main line. Now, there's not a ton of evidence for that, as we discussed in our video yesterday, but some of the high-res models are showing some semblance of some discrete supercells right ahead of the main line. And this is the environment they're going to be going in, both the line and any discrete supercells that form very moist low levels, very deep moist layer, all the way up to about 600 millibars there. That's extremely, extremely saturated in the low levels. That may or may not work to temper the overall instability with this event. We do have mixed layer CAPE above 1,200 joules per kilogram there. But look at the wind profile. Very, very favorable wind profile for severe weather, including tornadoes. Very strong veering of the winds, clockwise curvature with that low level photograph there. And so there should be quite a few embedded circulations within the line, and any discrete supercell out ahead of the line will be able to take advantage of this very strong wind shear profile, and will have the potential to produce strong tornadoes. Of course, we saw the SPC had the strong tornado threat out ahead of that line for parts of East Texas into northern Louisiana. Any discrete storms will best be able to take advantage of this environment, this very strong low-level shear, and have the potential to produce tornadoes, perhaps some strong. Damaging winds will also be a threat, especially along the line, because we have very strong winds aloft, and it's not going to take a lot to get those down to the surface via downdraft. So very strong damaging winds will be a threat with the system. Would not be surprised to see them put in a hatching with this 30% area, given the potential for significant damaging winds with the squall line especially. So squall line will continue, and let's look at, I want to compare just quickly the GFS and the HER runs. So let's look at the overall moisture return. Let's look at 18Z on Tuesday. So this will be noon on Tuesday. You can see the warm sector, those red contours, the lifted index where it's destabilized there. Very pinched off toward the north, very much wider to the south. But you can see it's well back into northeast Texas here, whereas the GFS has much more of a robust moisture return up here into northeast Texas, a little bit more progressive nature with that, but a little bit wider warm sector up here with northern extent. And so we're still seeing some model differences. Let's also look at the 12Z HER run, high resolution model that will maybe help us to analyze the warm sector. Similar to the NAM, a little bit more progressive maybe. There's the cold front kind of pinched off with northern extent, a little bit wider warm sector to the south. And so the overall situation looks like with northern extent there may be a little bit more of a tendency for the warm sector to become pinched, a little bit more room for possible discrete storms ahead of the line down to the south. But nonetheless, this entire line along this front will have severe storms ongoing into tomorrow afternoon across northeast and east Texas into western Louisiana. Before the threat moves off toward the east come Wednesday, there actually is a risk area for day 3, slight risk there. The potential for all severe hazards does exist here as that line continues to push off toward the east, and any discrete storms out just ahead of it will have the chance to produce damaging winds and maybe a few tornadoes there. And then by day 4, Thursday, we will see the extension of that threat as that line moves into the Florida Peninsula. So one last thing here, let's take a look at some high-resolution models here. We're going to go through a few high-resolution models just to kind of get an ensemble look at what the possibilities the radar might be showing later this evening. This is the 12Z HER, so we'll start off here. So we'll go by 0Z. By about 1Z, we start to see our first semblance of storm development up here into western Texas, or western Kansas. And then by between about 9 p.m. and midnight, we start to see an increase in coverage and intensity with these storms down here from southwest Kansas through the eastern Texas Panhandle, northwest Oklahoma. You can see some more discrete elements in here. Try to remain a little bit more discrete there. So any discrete storms would have a chance to take advantage of that very impressive looking sort of cold core profile there. Very strong low-level instability, very strong low-level shear. So would not be surprised to see a few tornado reports here as long as storms can become surface-based in this area, which the NAM model was showing, despite surface temperatures and dew points in the low 50s only. That, again, that cold air aloft is going to help really destabilize the atmosphere and help erode that cap as that forcing moves in. Then as we go into the overnight hours, we really start to see a more clustered, sort of linear organization to the storms as that forcing really takes over and that cold front surges off toward the east. Let me switch to our southern sector here so you can get a better view into Tuesday. So again, that line starts to form. Line will maintain itself through the morning hours Tuesday. Again, Dallas-Fort Worth metro area. Morning commute may be a little dicey tomorrow, given that storms will be moving in around that time, perhaps with some sporadic severe reports in that line. That line continues to move off. That forcing will maintain that line, but you can see these little beans. The HER is starting to model some of these little beans out across far east Texas into western Louisiana, out ahead of the main line. That may have, again, the threat for them is somewhat conditional, but if we can get these to develop, they will have the best chance for producing strong tornadoes and damaging winds. But nonetheless, there will be strong damaging winds possible and some embedded tornadoes along the main line. that'll be something we have to watch. Her is progging quite a few discrete supercells out ahead of the main line into Louisiana as we go into the late afternoon, early evening hours Tuesday, before the line then kind of moves off toward the east into Wednesday morning. Now let's go ahead and take a look at the ARW model here. Just another convective allowing model that we can look at. Again, you never want to look at just one convective allowing model. You want to look at a multitude of them to kind of get an ensemble look at what kind of possibilities there are. So initial semi-discrete storm development down here, not as much farther north with this particular model, more so down south into southwest Kansas, the eastern Texas Panhandle, northwest Oklahoma there, before congealing into a line pretty quickly going into the early hours of Tuesday morning. We'll shift down to the southern sector here, see what it's progging for the Tuesday portion of the event. So that line continues to move through. And interestingly enough, this line looks like some of these solutions may start to have the line devolve into discrete elements. And the day 2 outlook, the new day 2 outlook that just came out, actually highlighted that here. You can see in the outlook, some of the guidance even hints at a transition to more of a discrete mode across central portions of far east Texas and far western Louisiana. Vertically varying wind profiles will still be in place, and a more discrete mode would favor supercells capable of all severe hazards, including tornadoes. 1 or 2 strong tornadoes may occur. So SPC is also noting that maybe the original kind of solid line will devolve into supercells. And the way that happens is if you get the front to kind of slow down a little bit, or if we get shear vectors to be a little bit more perpendicular with time in orientation to the overall initiating boundary. So we'll have to keep that in mind tomorrow, that we may start to see a devolution of the main line into supercells, plus the threat for discrete supercells out just ahead of the main line here in East Texas into far western Louisiana. So, and especially overnight, we start to see that line push through into the early morning hours Wednesday. Let's look at the NSSL WRF here as well. We'll go back to our central sector here. And so with the NSSL WRF, we start to see kind of semi-discrete development there, similar to the ARW there by midnight. I always kind of subtract a couple hours from these convective allowing models. So definitely an after dark event for sure. And then we start to see a congealing of of the storms into a line with time. So very similar progression to the other convective allowing models. Let's see what it has for the Tuesday portion of the event. And you can see that we may start to see a devolution into a more discrete mode. We're starting to see some discrete elements here, and this maybe has me a little bit more concerned, as the wind profiles out ahead of this line in the warm sector are very, very favorable for tornadic supercells. So if this main line can devolve into more semi-discrete or discrete elements, plus the threat for isolated storms out ahead of the line, then we may be talking about a more significant severe weather event than what is being currently forecast. So very interesting development here. Last model we'll look at is the FV3, and I'm just going to start here with the southern sector. It does actually have some fairly discrete elements here, and take this with a grain of salt. The FV3 is very aggressive with its convective coverage often, but we do get some semi-discrete elements here in southwest Kansas right around midnight or so. Again, we'll have the potential to produce some damaging winds, large hail, and tornadoes there. Then more of a line down to the south as that cold front starts to surge through. Then going back to the southern sector here, and we'll go through with time and see what it's showing here. So kind of a solid line here with time. And then we do get some kind of discrete sort of updraft helicity streaks here. So as we go into the late afternoon and evening hours, we're really going to have to watch that main line to see if it does devolve into discrete supercells. Again, plus that threat for supercells out ahead of the main line. So very interesting setup here. Something that we're going to have to watch going into tomorrow. But overall, anyone in these outlook areas, especially tonight in this slight risk area, northwest Kansas into the Oklahoma Panhandle and eastern Texas Panhandle to western Oklahoma, northwest Texas, places along the I-70 corridor near Colby, down to Garden City, Dodge City, Liberal, Woodward, Canadian Texas, Pampa, down toward Childress, Vernon, Wichita Falls, Seymour, Texas, all in the greatest threat for this evening. Again, tonight will be an after dark threat with all severe hazards possible. Going into the morning hours Tuesday, places like the Dallas-Fort Worth metro area, Waco, even up toward Norman, Oklahoma City and Norman maybe get in on the threat just before sunrise here on Tuesday morning. Threat for, again, North Texas, Dallas, Fort Worth area will be Tuesday morning before the threat shifts into East Texas and northern Louisiana, with the threat for maybe a strong tornado or two, some damaging winds, and maybe some large hail out there across that enhanced risk area, places like Lufkin, Texas, Shreveport, down to Alexandria, under the gun for the greatest threat tomorrow. And then on Wednesday, that threat continues into the Gulf Coast states, southeast Louisiana, southern Mississippi, southern Alabama, Florida Panhandle, with the threat for damaging winds and a few tornadoes there, and then into the Florida Peninsula on Thursday. So with that, that'll do it. Thanks for watching. We'll see you in the next video.